Morning. Good morning. Good morning. Welcome, all of you. Good morning. Welcome, everybody. Good morning. All right, just to let you know, there is a way to chat also. Just in case you have any questions, you can chat there or we can chat here. Welcome, everybody.
Cherry.
Hello, hello, I can hear you. Good morning.
Good morning.
You can say hi to your friends, to everybody. That is okay.
Hi, good morning.
Good morning, everybody.
Hey. There's like no one in here.
Well, I see. Yeah, there are already 14. Morning, Sherry.
Good morning.
Morning, everybody. We're 15 now. Pretty good. All right, you guys. I'm glad to see you and to hear you again. Some of you I can see you. Some of you I'm gonna be able to hear you guys. You downloaded the lectures. You might have it with you right there, which is really good. Very good. We're gonna continue with 5.3. And again, you have your handouts with you. You can see the title and the objectives, by the way. All right. So all right. So let's start our lecture. Again, good morning and welcome again. Glad to hear you and to see you again. All right. So again, let's start with 5.3. Hopefully everybody's ready with your coffee right there. And 5.3 is properties of rational functions. Properties of rational functions. All right. So remember that everybody can hear what you guys doing. Okay. So just to let you know. Just to let you know that everybody can hear everything that you're doing or saying. All right.
All right.
Ready? Okay. All right. So let's continue with 5.3. There's somebody there making a little bit of noise. Getting ready. All right. All right. So what are the objectives of 5.3? Notice it says find the domain of a rational function. Find the vertical asymptotes of a rational function. And last, we're gonna find the horizontal or the oblique asymptote of a rational function. All right, so let's start with the definition, what a rational function is. Notice, a rational function is formed when you divide a polynomial by another polynomial. In other words, R of X is equals to P of X divided by Q of X. It says where P and Q are polynomial functions. Notice what it says here. The domain of R, the domain of R of X, is the set of real numbers except those for which the denominator Q is equals to 0. All right, so we're gonna find the domain of some example right here. Notice example, find the domain. So we're gonna start with A. Okay, I hope everybody's okay. And again, if you guys can tell me everything is off or not focused, please let me know and I'll do that, okay, for you guys. I can do that for you. Notice, pretty good, notice. Let's find the domain. Let's start with A. Notice, I already found the domain, but let's go step by step here. We said that the domain of a rational function are all the values except the values that would make the function undefined. Notice, the function is f of x equals to 1 over x. The question is, which value of x makes the denominator equal to 0?
The 0?
0, right? Thank you, Cherry. X equals to 0 makes the denominator undefined, by the way, or make the function undefined. So now that we found the values that would make the function undefined, those values, we're going to exclude those values from the domain. So we're going to exclude 0 from the domain. So the answer in interval notation is from -infinity to 0. And we're going to exclude the 0 by using the u and from 0 to infinity. That's interval notation. Or if you want to write it as in another notation, which is set builder notation, that would be for all x such that x is different from 0. That would be the answer for A. Any questions so far for A? We're good?
Yeah.
Yes.
All right, pretty good. Now let's go with B. Notice, B, the function is R of x equals to 3 over x plus 3, right? So first, let's find the value that would make this function undefined.
So -3?
Yes, thank you. You're right. -3. Some of this function, notice, is obvious, right? You can tell as soon as you see it. So first thing that we're going to do to find those values that would make it undefined, let's equate the denominator equal to 0. So what I'm going to do is I'm going to start with x plus 3. I'm going to equate it to 0. And then from there, we're going to solve for x. So from here, we can tell that x is equals to -3. So -3 makes this function undefined. So that means that to write the domain, we're going to exclude x equals to -3. So the domain in interval notation, would be from -infinity to -3. We're going to exclude the -3 to infinity. And that would be the answer. Ready? So if you want to write the answer and set builder notation, you can also write it. And that would be for all x such that x is different from -3. So that would do it. All right? Okay, so seems that we're okay so far. All right, so let's try C. All right, so let's try C. And I'm gonna give you a couple of minutes for you to try C. So first thing that we're gonna do for C, we're gonna equate the denominator equal to 0. And since we have a trinomial there, we're gonna factor that trinomial. I'm gonna give you 1 minute for you to try it. And after we factor that trinomial, we're gonna solve that trinomial. And from there, we're gonna know the values that will make that function undefined. So again, start by equating the denominator equals to 0. And then from there, all right, for some of you, just to let you know, all the noises that you're making, everybody is listening to to what you're saying, okay? Just to let you know. All right, so let's factor x squared plus 2x plus 1. Try big X. Let's see if that works. So if we try big X together.
Is it -1?
Well, let's see. Let's give it a try. Let's see. That would be -1. Thank you, Cherry. Let's try big X here. Notice I want to write the 1 here and the 2 here, right? And the factors of 1 that would give me the answer is 1 and 1, right? 1 times 1 is 1. 1 plus 1 is 2. So this is the same as x plus 1 times x plus 1, right? Which is equals to 0, which is the same as x plus 1 squared, right? And that's equals to 0. And if we solve x plus 1 equals to 0, so that would be x equals to -1, right? So x equals to -1 is the value that makes this function undefined, right? Remember, this is not the domain. The domain, in order to write the domain, we need to exclude this value, right? Correct? So let's exclude this value right here, and that would be from -infinity to -1, union -1 to infinity. All right, so that would be the answer. Is that clear, you guys? Is that clear how to find the domain of a rational function?
Yeah.
All right, perfect, pretty good. Remember, you can also chat here, and you can show me your answer if you wanna write it here. There is a group chat right there that you look around. There is a group chat, you guys, and you know, you can also enter your answers if you can right there, or if anything that you want me to go over, you can also type it, okay?
Is this being recorded so we can look at it later?
Yes, yes, it is being recorded, definitely. You guys can go over again. Yes,
Okay.
good question. All right, so let's continue to the next page.
I have a question,
Yes.
Professor.
Yes.
Where can we find if after we done?
Oh,
find it?
I'm gonna send you the link. It's gonna be uploaded to YouTube. I'm gonna email you the link, you guys, so that way you can click on the link, and that will refer you to where the video is.
Okay, thank you so much.
You're welcome. All right, now that we know how to find the domain, let's continue to the next page, and we're gonna be now right there, asymptotes. So what are asymptotes, by the way? Well, we have two kinds of asymptotes. We have vertical asymptotes and we have horizontal asymptotes. Well, there are three kinds, by the way. And also we have oblique asymptotes, by the way. So we're gonna start by finding the vertical asymptotes first. So what are the vertical asymptotes? It says values that make a rational function undefined. Notice, we already know how to find the values that make a rational function undefined. So those are the vertical asymptotes. All right. So let's try to find the vertical asymptotes for these rational functions, which is very similar to what we did already. If we start with A, you guys right there, notice again, first thing that we do, we make the denominator equals to 0, and we solve for x. And now here, if we solve, notice x plus 4 equals to 0. We solve for x, that's x equals to -4. So the -4 is the vertical asymptote. Okay, so remember, asymptotes are imaginary lines. So we're gonna be using vertical asymptotes and horizontal asymptotes and oblique asymptotes for the next lecture where we're gonna start graphing rational functions. All right, so let's continue with B. Let's continue with B, notice, and let me give you a minute for you to try to find the values that would make g of x undefined. So let's give it a try. Let me give you a minute. Same steps as before. Make the denominator equals to 0 and solve for x.
I got 2.
Okay. You might be missing a value, Cherry. We're gonna get 2 values from here.
Okay.
2 and negative 2.
All right. That would be
if we get a
Oh yeah,
square
because
root of,
the square root.
yeah, it's
yes.
negative and positive 2.
Yes, you're right, you guys. Yes.
Yeah.
All right.
Can you write it down and show me?
Sure, definitely. I wanna write it. Definitely. So notice is this is x squared minus 4, right? Well, let x squared, let me do it right here. Let me just focus here. All right, so let's do it together. Is x squared minus 4 equals to 0, all right? And then solve for x. X squared equals to 4. Here we're gonna apply the square root property, right? So the square root property is x equals to plus minus. Don't forget the plus minus the square root of 4. We're applying the square root property right here. So x is equals to plus minus 2. Here, these 2 values, that's where the vertical asymptotes are gonna be located, at x equals to plus minus 2. Ready? Okay, so let's try C now. Let's try C. For C, we have R of x.
Professor, I have a question.
Sure, yes.
Do we have 2 asymptotes, that's negative 2 and positive 2 for?
Yes, we got 2 asymptotes, yes. We got 2 asymptotes.
How can we, if we have 2 asymptotes, how can we graph this
Oh,
equation?
well, let me do it right here. Notice, and we're gonna do it in the next section, but let's do it right here. Locate positive 2 and negative 2, negative 1, negative 2, 1, and 2. And what you're gonna do is you're gonna draw 2 vertical lines at 2. Let me do it with different colors here. And at negative 2. That's how we're gonna be drawing the asymptotes. These are the vertical asymptotes. All right. And we're gonna learn in the next section that when we start graphing, a graph never crosses a vertical asymptote. Okay, these lines are imaginary lines, by the way. Okay. All right, so let's try C. Let's try C. Let me focus that. Oh, give me 1 sec. Right there. It says R of x equals to x divided by x squared plus 1. The question is any value, you guys, any value that will make the denominator undefined? Solve for
I
x.
think we got an imaginary number.
Yes, we have an imaginary number. So let's see. What do you think that let us know? Let me get to where you guys are right now. So if we solve for x, that would be negative 1, right? Yeah. Then if we apply the square root property, that would be x equals to plus minus a square root of negative 1. What is the square root of negative 1? I. Yes, you're right, everybody. You're correct.
Would it just be I or would it be I1?
It's just I. The 1 is implied. That will be plus equals to plus minus I right there, okay? So Probably I mentioned this before, but when you guys solve for X and you get an imaginary numbers, what this tells us is that the graph will never cross the X-axis. Is that clear?
Yeah.
Okay, so here we don't have a vertical asymptote, but if we graph this function is above the X-axis. Okay, so if you want to write a note here, so the domain, let me just if I was asking you, this one does not have vertical asymptotes to begin with. That would be the answer. Okay, no vertical asymptotes. Let me write it. No vertical asymptotes. That would be the answer. And if I ask you what is the domain of R of X, the domain would be from negative infinity to positive infinity, because this is above the X-axis. All ready? Okay. Now, any questions so far?
No.
All right, perfect. Thank you. Now, let me focus here. Right there. Now we're gonna find a horizontal or an oblique asymptote. By the way, I uploaded a handout, you guys, and I'm gonna put it in front right now. And this handout, and some of you probably downloaded it or not, but here it tells us how to find the vertical asymptotes, which we already did, okay? But also in the bottom part, it also tells us how to find the horizontal asymptotes, the horizontal or oblique asymptotes. Okay, so I'm gonna go over this handout right here, and it's very easy to understand, by the way. Okay, notice, let's start with the rational function R of X, which is P of X over Q of X, right? So, and you notice there are the notation of the polynomials here, P of X and Q of X. And let's concentrate on the leading terms, A sub n and X to the n. That's the leading term in the numerator. All right. Okay. And the leading term in the denominator is B of m, X to the m. So we're gonna concentrate on these two leading terms, and also in the degrees of the leading terms, in m and n. All right. And we're gonna go case number 1. It says if n is less than m. What is that? The degree of the numerator is less than the degree of the denominator. If that happens, the line y equals to 0 is a horizontal asymptote. What is the line y equals to 0? The line y equals to 0 is the x-axis, by the way. Probably some of you mentioned that, okay? So if m is greater than n, if this m is greater than n, then the horizontal asymptote is gonna be the x-axis, all right? Let's go to case number 2. If the degree are the same, if n is equals to m, the degree of the numerator equals the degree of the denominator, the line y equals to a sub n over b sub m is a horizontal asymptote. What would be those values? These values, the leading coefficients, a sub n divided by a sub m. That would be the horizontal asymptote if the degrees are the same. Now, let's go over case number 3. If n is equals to n plus 1, what is the meaning of that? If the degree of n is 1 greater than the degree of m, okay? If the degree of the numerator is 1 more than the degree of the denominator, it says the degree of the numerator is 1 more than the degree of the denominator, the line y equals to ax plus b is an oblique asymptote. So anytime that the degree of the numerator is 1 more than the degree of the denominator, we're going to have an oblique asymptote. What is an oblique asymptote, you guys? An oblique asymptote is a line that is not either a vertical line or horizontal line, okay? So it has an angle, by the way, which is the quotient found using long division, okay? So in order to find the oblique asymptote, we're going to be using long division to find it, okay? That's case number 3. Case number 4, it says that if n is greater or equal to n plus 2, the degree of the numerator is 2 or more than the degree of the denominator, there are no horizontal or oblique asymptotes. It says the end behavior of the graph will resemble the power function, okay? So for this case, we're gonna find the power function, which is the division of the two coefficients and the division of the two leading terms, by the way. That will be the power function. All right, so let's try this concept here with one of the examples that we have here. So let me move it right here, and let's try A. I tried A already myself, but let's go over A here. Notice first, we're gonna concentrate, in order to find the horizontal asymptote, we're gonna concentrate on the two leading terms. In the numerator, we have 3x, and in denominator, we have x. Those two are the two leading terms. Now, let's compare the degrees. Notice the degree in the numerator is 1, and the degree in the denominator is 1. So the degrees are the same. So this is for case number 2, by the way, where n is equals to m. And notice it says, since the degrees of the leading terms in the numerator and denominator are the same, then the horizontal asymptote is equals to a sub n divided by b sub n, which are the coefficients, by the way. So the horizontal asymptote would be 3 divided by 1. 3 divided by 1, which is equals to 3. Or y is equals to 3. Remember, y equals to 3 is a horizontal line at y equals to 3. If I wanted to graph this line, I can do it really quick here. And let me do it right here. At 3, 1, 2, 3. 1, 2, 3. You can draw a horizontal line right there.
What if the horizontal asymptote was like the degree was different?
Well, we're gonna try that. That would be probably for B.
Okay.
Okay. So, but basically, this is how you guys draw the horizontal asymptote. Just a horizontal line at y equals to 3. Okay. By the way, graphs might cross a horizontal asymptote, by the way. Okay. It never crosses a vertical asymptote, but it might cross a horizontal asymptote. All right. So let's try B. Let's try B. Okay. So for B, notice that again. Let's go over the degrees of the leading terms. And
Wait, I have a question.
sure, Cherry. Yes.
When you're talking about the leading terms,
Yes.
are you talking about like the exponent, or are you talking about like
The leading terms, Cherry and everybody, are the terms, the leftmost term in a polynomial. The leftmost term on the polynomial.
Okay.
In other words, the leading term is the term that has the highest or the greater degree in a polynomial. That will be the leading term. Make sense?
Yeah.
The term that has the greater degree in a polynomial is the leading term. Already? Okay. And if you notice here for B, you guys, in the numerator, the leading term is the one that we have. That's the only one that we have. That would be, the degree would be 3. And in the denominator, the leading term is x to the 4. So the degree is 4. Now let's compare the degrees here. Notice for this, for B, if we go back to the, let me put it back here, to the rules that we have right here. This applies to case number 1, where m is greater than n. The degree of the denominator is larger than the degree of the numerator. So here, the line y equals to 0 is the horizontal asymptote, okay? So let me write it here. I'm gonna write since 4 is greater than 3, then the horizontal asymptote is the line y equals to 0. What is the line y equals to 0, by the way? Let me focus here.
On the x-axis.
You're right, that's the x-axis. So that would be the x-axis. That would be the horizontal asymptote. Let me write it here. Or the x-axis. That would be the horizontal asymptote. By the way, pretty good.
I have a quick question.
Yes,
So for number 1, now I know it's the degrees, but how did you get 3 for the first one?
Sure, yeah, let's go back to A, okay? So notice, let's always compare the degrees of the leading terms. Since the degrees are the same here for the numerator denominator, right? Okay, so that is for, let me put it back. That's case number 2 here. Let me just write there. Where n is equals to m, the horizontal asymptote is gonna be the division of the coefficients, by the way. The division of the coefficients. Okay, so that would be the answer for that. And what is the coefficients here? The coefficients are 3 over 1. That's what I wrote here, 3 over 1, which is equals to 3. All right, make sense?
Yes.
All righty, good question.
Question for
Yes.
A, Professor.
Yes.
You just put the asymptote y equal to 3. If we graph the x plus 4 or whole equation, how do we graph it?
Well, that's what we're going to do next section, Mohammed.
Okay.
I'm confused as far as like you saying y equals 0 or the x-axis. Can you explain that?
Sure, definitely. If I ask you, which is the same, by the way, if I ask you graph y equals to 0, and let me do it right here, okay?
Okay.
I'm gonna do it right here. If I ask you graph y equals to 0, this is x, this is y, that would be the line on the x-axis.
Oh, okay. Makes sense.
That's the x-axis. Okay?
Yeah.
Alrighty, pretty good. All right, so let's try C, you guys. Now let's try C. C, notice that's x cubed minus 8 divided by x squared minus 5x plus 6. So, all right, okay. So, which case you think this C applies? Notice the degree of the numerator is larger than the degree of the denominator. All right, let me put back the rules that we have here.
It's the third one, right?
Yes, you're right. Yeah, the third case, it says the degree of the numerator is 1 more than the degree of the denominator. It says the line y equals to ax plus b is going to be the oblique asymptote. Here we're going to have an oblique asymptote, you guys. How we're going to find that? We're going to be using long division. Remember long division? So if you guys don't remember, we'll remember right now, okay? So let's do it together. All right, so again, this is how we set up long division. That would be x cubed. By the way, if you guys remember long division, let's start with the x cubed. Notice in the numerator, we start with x cubed, but notice that we're missing x squared and x, right? Do you notice that? And then we have the 8, correct? if we're missing some of the terms, we're gonna use 0 as a placeholder, by the way, okay? So this is what we do. X cubed plus 0x squared plus 0x minus 8. Alrighty? And then we're gonna divide by x squared minus 5x plus 6. Okay? All right, so if we remember long division, how do we find the first term in the quotient, right? We get the leading term in the dividend, which is x cubed. I'm gonna do it right here. And you divide it by the leading term in the divisor, which is x squared. And the question is, what is x cubed divided by x squared?
X.
X, right? Thank you. Now that we have this x, we're gonna place this x on top of 0x right here, right there. All right? And then we're gonna start multiplying now. What is x times 6? That would be 6x, right? So you place the 6x right here. Let me use a different color here. X times 6 is 6x right here, right there. And then what is x times negative 5x? That would be negative 5x squared. And then what is x times x squared? That would be x cubed. All right, everybody okay? But remember that when we're using division, a normal division, we always negate, right? So we're gonna negate these terms right here. And now this negative sign is gonna be affecting the sign of the terms inside the parentheses. So the x cubed becomes negative. Well, let's see, I don't want you to, becomes negative because of the negative sign. This plus, this negative here becomes, because of this negative, is gonna become positive here. And this positive, because of this negative, is gonna become negative, all right? And then let's add these values right here. Let's see what we get here. So notice x cubed minus x cubed, this becomes 0 right here. 0 plus 5x squared, here I got 5x squared. And this 6x became negative because of this negative sign. That would be 0 minus 6x. That would be negative 6x. And bring down the negative 8. Bring down the negative 8 right here. All right? Okay. Next, let's continue. Let's get the next term in the quotient. That would be get the 5x squared divided by x squared. Again, the first term in the remainder, which is 5x squared, divided by the first term in the divisor. So now what is 5x squared divided by x squared?
5.
That would be 5. Thank you. All right. So we're going to place this positive 5 in the quotient, which is now plus 5 here. Plus 5. All right. And then we're going to do the same as we did before. We're going to multiply 5 times 6, which is 30, and we're gonna place it right here underneath the negative 8. And 5 times negative 5x, which is what? Negative 25x. Ready? And then 5 times x squared, which is 5x squared. Again, we're gonna do the same. We're gonna negate. And let's see how the signs inside the parentheses is gonna change because of this negative sign. This is gonna become negative, negative, negative. This is gonna become positive. And here, this one is gonna become negative. And we're gonna add the terms here. 5x squared minus 5x squared, this becomes 0 right here. Negative 6x plus 25x. That would be 19x, positive 19x. -8 minus 30, that would be -38. And notice that would be the remainder. So here, we're done with the long division. How do we know we're done? Notice, always check the degree of the leading term and the remainder, which is x. Notice this is one less than the degree of the divisor. That's how you know you're done with a long division. Now, what would be the answer? What would be the oblique asymptote? All right, here again, we have an oblique asymptote. Oblique asymptote. And that would be y equals to x plus 5. So in the next section, you guys, we're gonna be graphing y equals to x plus 5. So why don't we do it right now, just for practice, okay?
What
So,
are we doing with the 19x minus 38?
no,
We just need to do.
For now, in the next section, we're gonna consider that to find more values that we need to graph. For just to find the oblique asymptote right now at this point, this is what we care right now, the oblique asymptote. Okay.
Yeah.
So let's graph y equals to x plus 5 really quick. Okay, that would be a good practice for the next section. All right. Notice this is a linear equation, right? So let's use the slope. Notice the slope is equals to 1/1, right?
Yeah.
And the y-intercept is what? Is 5, right? As a point would be 0,5, correct?
Yeah.
All right, perfect. So again, we always start with the y-intercept. So let's start with 0,5. So let me scale it here. 1, 2, 3, 4, 5. All right. So 1, 2, 3, 4, and 5, 6, 7, and 8. All right. At 5, 1, 2, 3, 4, 5. I start 5 right there. And then I'm gonna use the slope. Notice the slope is 1/1, right? What is the meaning of that? I'm gonna go up 1 and 1 to the right. So from 0,5, which is right here, I'm gonna go up 1. Let me scale it. Excuse me. Let me scale it on the x-axis, y-axis. 1, 2, 3. So I'm gonna go up 1 and 1 to the right. You wanna get more points, go up 1 and 1 to the right again. So now that you have these points, connect these points with a dotted line, So that dotted line, that is the oblique asymptote. Okay, you guys, that's the oblique asymptote. All right, so this is just a refresher how to graph lines.
Like I'm gonna forget how to do it because like the steps, like the long division looks a little complicated.
We might try it again the next section. Okay.
Yeah, I feel
try
like
again.
yeah, it'd be nice if you gave us more examples on like C.
All right, so we're gonna try. Definitely, we're gonna try one more or probably two more. Okay.
Okay.
Alrighty. So let's see. We're gonna try now. Let's continue with this page, which is the last page of this section. It says, example, graph using a transformation, then find the domain, the range, the vertical asymptotes, the horizontal asymptotes, or oblique asymptotes, okay? So notice here, r of x is equals to 1 over x minus 1 squared. Okay, so we're gonna be using transformations here, okay, to graph it. I don't know if you have your handout with you, like the basic functions, the handout that I gave you some time ago. And if you guys have it right there, please look at this function. Look at f of x equals to 1 over x squared. You have it right there. Please look that function. That would be the basic function that we need to look at. 1 over x squared.
Oh,
All right.
it's a reciprocal.
Yeah, no, it's not the reciprocal. The reciprocal is 1 over x, right? Do you have 1 over x squared somewhere there? Cherry, check.
That's what it, look.
Oh, that's the reciprocal square. All right, there are two. Oh, thank you, Cherry. That's two reciprocals, by the way. It's 1 over x and 1 over x squared, okay? So this would be the reciprocal square, okay? Pretty good, thank you. So see how it looks, you guys?
Yeah.
All right, so notice, let's go back to r of x. This is x minus 1 squared. So that means that the reciprocal squared is shifted by 1. Is it to the right or to the left, you guys?
It's to the right.
Yeah, it is shifted 1 to the right, by the way. Okay? How do we know that? Because x minus 1, right?
X minus 1 equal to 0, and then
Yes,
x equal to
correct. 0. Yes, you're right. So if I continue right here, you guys, if I get x minus 1 equals to 0 and I solve for x, that tells me how this function is shifted to the right 1 unit. So if we want to graph it, and let's do it really quick, this is how the graph is going to look. By the way, what is x equals to 1? It's a horizontal asymptote, it's a vertical asymptote. What kind of asymptote is that?
It's a vertical asymptote.
It is a vertical asymptote. You guys are right. It's a vertical asymptote. Okay, so x equals to 1, which is the same as the vertical asymptote. X equals to 1. Okay.
How is it a vertical asymptote again?
Remember, remember the steps to find the vertical asymptotes? What we do is we equate the denominator equals to 0 and we solve for x. And that value would be the vertical asymptote. Remember, vertical asymptotes are values that make the function undefined. How do you find those values? Make the denominator equals to 0 and solve for x. Okay, that's how we find the vertical asymptotes. So if we want to graph the vertical asymptote, let's graph it at x equals to 1. 1, 2, 3. And all we got to do is at 1, that would be the vertical asymptote. Let me just go down a little bit here. Is that clear? That's the vertical asymptote. Okay. And all we got to do, go back and refer to the reciprocal squared function that you guys have. And let's just follow the same shape that you guys have. And notice it's going to go this way. So here we are using transformation. Remember, transformation is a very easy way to graph. Oh, by the way, let me ask you one more question before we continue here graphing. What would be the horizontal asymptote? Let's find the horizontal asymptote. What is the horizontal asymptote? Here. So let's compare the terms. I mean the degrees of the leading terms in R of X. Okay, let me rewrite it here, okay, to find the horizontal asymptote.
It's a little bit out of focus.
All right, thank you. I would.
Okay, yeah.
Much better? Perfect. So let me rewrite R of X because we want to find the horizontal asymptote, right? So here we got a 1, and here we have x minus 1 squared, right? So remember, in order to find the horizontal asymptote, we're going to compare the degrees of the leading terms, right? So I'm going to use this trick, okay? Notice, in the numerator, can I do this? 1, and can I write x to the 0? Remember, any base raised to the 0 is equal to 1, right? Correct? So I can do this trick here in the numerator. 1 times x to the 0 is the same as 1. Is that clear? In the denominator, if I square this binomial, this is what I'm going to have. The square of the first minus 2 times the first times the second plus the square of the second. Notice r of x is the same. These two functions are exactly the same. Now, what I did, now I can compare the degrees now, the two leading terms, right? Notice the degree of the denominator is larger than the degree of the numerator. Which case is that? Okay, so let's compare the case here. The degree of the numerator is larger than the degree of the numerator. That would be case number 1. Notice case number 1. And for case number 1, the line y equals to 0 is the horizontal asymptote. So here, again, since the degree of the denominator is larger than the degree of the numerator, the horizontal asymptote is equals to y equals to 0. So I'm going to draw the horizontal asymptote here on the graph. And it's going to be right here, by the way, right here, right there, on the x-axis, by the way. All right?
Can you move the paper up so I can see a little bit?
Sure.
Like further down. No, like move it up. Yeah.
Right there? Very
Yeah.
good. Nice. So notice here how the graph gets closer and closer to the vertical asymptote, but it will never touch the vertical asymptote, by the way. And it goes down, and it will never touch the horizontal asymptote, neither. That's the same on the left side of the vertical asymptote. Remember the end behavior, you guys? All right. So we can also apply the end behavior here. Any questions, you guys, here for A? All right. Probably that means no. Okay. So we're not going to do B, but I want you to try B, but it's very easy. Notice here, B, the basic function will be the reciprocal function, 1 over x. Okay. Notice it is shifted to the right 1 and 1 unit up. Okay. So you guys can try that one. All ready? So with this exercise, we're done with 5.3. So let's continue with 5.4. 5.4. Let me know if you have any questions so far. And let's start. Let me put this away here. I'm gonna focus 5.4 here. Notice 5.4, the graph of a rational function. Now we're gonna be using the knowledge that we learned in 5.3, by the way, okay? That's gonna be the graph of a rational function. The objective is graph a rational function, okay? That would be the objective, graph a rational function. So let's give it a try. You know what, let's see, I might have, you know what, let's see. Well, let me start with one that would be a little bit easier for everybody, and then we'll try another one, okay? So let's start, we're gonna start with C right here. We're gonna graph this rational function, f of x equals to x plus 1 divided by x times x plus 4, right? And we're gonna go step by step, okay? We're gonna go step by step. So step number one, we're gonna find the domain. Find the domain, okay? We're gonna find the domain. All right, if you guys remember from 5.3 how to find the domain, first thing that we're gonna do is we're gonna equate the denominator equals to 0, and we're gonna solve for x. So let's do that. X times x plus 4 equals to 0. And let's solve for x here. Here, x equals to 0, or x plus 4 equals to 0. So the two values, x equals to 0, or x equals to -4, right? Okay, these two values makes this function undefined. These two values are not part of the domain, by the way. Oh, excuse me. Sorry about that. It was my phone. Let me mute my phone. Sorry about that, you guys. All right, I did it. My apologies. All right, so again, this is not the domain. We're gonna exclude these two values from the domain. So the domain would be from -infinity to -4, excuse me, to -4. We're gonna exclude the -4 to 0, and we're gonna exclude the 0 to infinity. All right, so that would be the domain. So everybody okay? That would be the domain. Any questions so far?
No.
No,
All right,
thank you.
perfect. All right, so now also we're gonna find the range, but we're gonna skip 2. Well, let me write it here. Number 2, find the range, but we're gonna exclude that for now. We're gonna answer that a little bit later, okay? So just give a space for 2. Number 3, we're gonna find the X-intercepts. Find the X-intercepts. So remember how to find the X-intercepts? We make f of x equals to 0, and we solve. Already? Okay, so we're gonna find the values of x when we make f of x equals to 0. So let's give it a try. So x plus 1 divided by x times x plus 4 equals to 0. We're gonna solve for x, okay? So every time that you have a rational function and you equate it to 0, you're left with x plus 1 equals to 0, with the numerator equals to 0. Why is that? Because if you multiply by x times x plus 4 in each side, the x times x plus 4 goes away, and you're left with x plus 1 with the numerator equals to 0 all the time, you guys. And from here, you solve for x equals to -1. So at x equals to -1, we're gonna have an x-intercept. In other words, the graph is gonna cross at x equals to -1. Ready? Okay, let's go with number 4.
Professor,
Yes.
Can you repeat this part? I confused.
Sure. All right,
Yes,
so
thank you.
here, let me go back here, okay? Let me go back here.
Why aren't we doing the bottom part too?
Because it cancels out.
Yeah, so let me go over here. I'm gonna show you more steps, okay? Let me go over again. This x plus 1 over x times x plus 4 equals to 0. If I wanna solve, if I equate to 0 here, if I wanna solve these rational equations, you guys, I'm gonna get rid of the denominator, which is x times x plus 4, okay? In order to get rid of that, I'm gonna find the least common denominator. What is the least common denominator? That would be x times x plus 4. So I'm gonna multiply, now that you found the least common denominator, multiply each side by the least common denominator, which is x times x plus 4. So I'm gonna multiply each side by x times x plus 4, and also the right side by x times x plus 4. Notice when we do that, you guys, on the left side, the x times x plus 4 in the numerator divides out with the x plus 4, x times x plus 4 in the denominator. These two divides out. So you're left with x plus 1 in the left side. On the right side, notice that you're multiplying 0 times x plus 4, and you're left with 0. That's how you're left with the numerator equals to 0 when you have a rational equation. Is that clear, you guys?
Yeah.
Yeah? All right. So if you solve for x, so x is equals to -1. So that's the x-intercept. Now, let's find the y-intercept now. Number 4, let's find the y-intercept. How do we find the y-intercept? Remember, we evaluate the function at x equals to 0. Okay? So let me go down here. So let's evaluate the function at x equals to 0. This is how it looks. F of 0. Let me rewrite the function. We have f of x equals to x plus 1 over x times x plus 4. Now let's evaluate. Let's find f of 0. That means that any x is now going to be substituted by 0. That's 0 plus 1 over 0 times 0 plus 4, right? And this is equals to what?
1 over 0, so undefined?
Yeah, you're right.
And
That would be
undefined,
1
yes.
over 0, which is undefined, right, everybody? So what is the meaning of that? That we don't have any y-intercepts. That's what it means, you guys, okay? It means that we don't have any y-intercepts. No y-intercepts. That's what it means. Ready? Okay. Now let's continue. Let me go back here. Now we're gonna.
Sir,
Yes.
why did we skip find the range?
Okay. We'll find it right now. Okay. Just give me 1 second. I want to tell you why. Okay. All right. So let's find because I need to find the vertical asymptote and the horizontal asymptote. And from there we can find the range. That would be easier for us. Okay. So let's find the vertical asymptote. What are the vertical asymptotes, you guys? By the way, we already found them. If you go back to question number 1, when we find the domain, since we equate the denominator equals to 0 and we solve for x, those values are the vertical asymptotes. Everybody remembers that?
Yeah.
All right, perfect. So we already found the vertical asymptote. So the vertical asymptote, you guys can get it from.
Will
Yes.
will the vertical asymptote always be the domain, like same?
No. Remember, don't get confused here. These values, and let me point it right here. X equals to 0 and x equals to -4 are not the domain. These two values are the values that make the function undefined.
Oh, okay.
Okay, the domain are all the values except these two values.
Okay.
The vertical.
But it'll always be that step.
Yes, I mean you have to do this step right here. All right.
It'll always be the vertical asymptote.
These two values will always do the vertical asymptote. So let me do it right here. That way you guys remember. Get the denominator again, x times x plus 4 equals to 0 and solve for x. X equals to 0 or x plus 4 equals to 0. So x equals to 0 or x equals to -4. These are the vertical asymptotes. Is that clear, you guys? Very good. Very good.
Yes.
So the vertical asymptote is just what makes the denominator undefined.
Yes, that would be the values that would make the denominator undefined. Pretty good. That's the right answer. Really good. Pretty good. All right. So now let's find the horizontal asymptotes now. Let's find, that would be a step, would be a step number 5, by the way. Step number 6, the horizontal asymptotes. Let's find the horizontal asymptotes, all right? And I'm gonna give you 1 minute for you to tell me what would be the horizontal asymptote, you guys.
Is it the y equals 0?
Yeah.
So do you guys agree with Terry, you guys?
Yeah.
Yes, it is. Yes, it is. All right. Okay, so let me tell you why. For the ones who didn't see it, let me if you're not sure, let me show you what to do if you guys are not sure. Because remember that in order to find the horizontal asymptote, we are always comparing the degrees, right?
Yeah.
Of the leading term. So do this, you guys. X plus 1. In the denominator, distribute the x. So you have x times x is x squared plus 4x. Now notice, now you can tell, you can compare the degrees now. The degrees in the numerator is 1, the degree in the denominator is 2. The degree in the denominator is larger than the degree of the numerator. Going back to the rules that we learned, that would be rule number 1. That means that the vertical asymptote is equals to y equals to 0, which is the horizontal asymptote, by the way.
I'm sorry, you rewrote it, you said x to the first power?
Yes, in the numerator, the x by itself, that means
I thought it was to 0.
No. No. If you have the x by itself, the degree is 1. It is implied. We don't write it, but it's implied.
Okay.
Okay, x to the 0 is equals to 1 by itself. But here,
Oh, okay.
okay, we used that trick before, but no, here's x to the first power all the time, you guys, okay? All right, so do we agree? I'm sorry, this is the horizontal asymptote. The horizontal asymptote is equals to y equals to 0, which is the x-intercept, right, everybody?
Mm-hmm.
Okay, now that I found the horizontal asymptote, you guys, now I can tell what the range is. Notice, at y equals to 0, we have a horizontal asymptote. Oh, so you know what? Let's start, we're gonna be graphing it. Let's start graphing it, this value, and I'm gonna tell you the range after we graph the horizontal and vertical asymptotes, okay? So let's give it a try here. So, all right. So let's start by graphing the points that we know. Let's start by graphing the vertical asymptotes and horizontal asymptotes. So we have 2 vertical asymptotes at x equals to 0 and at x equals to -4. All right. So 1, 2, 3, 4, 5. 1, 2, 3, 4. -1, -2, -3, -4, -5. Let me just scale a little bit more here. -2, -3. This is the x-axis, and this is the y-axis, right? So let's start with the 2 vertical asymptotes. X equals to 0 and x equals to -4. All right. Notice, what is x equals to 0? Well, x equals to 0, you guys, that would be the y-axis. All right, everybody agrees?
Yeah.
Mm-hmm.
So that would be the y-axis, okay? And x equals to -4. X equals to -4. At -4, draw another vertical asymptote. Is that clear so far?
Yes.
Yeah.
Now let's draw the horizontal asymptote, which is at y equals to 0. Okay, so that would be the x-axis, right? Right there. Okay, and now from here, you guys, I can tell you what the range is. Okay, but let's continue. Let's graph it first. Okay, so what are the x-intercepts? Let's go back to the x-intercepts. That would be x equals to -1, right? Everybody?
Mm-hmm.
Okay, at x equals to -1, plot this point right here at x equals to -1. That's where the graph is gonna cross the x-axis, by the way, okay?
Oh, so you don't put a line, you plot a dot.
No, just a dot right there at x equals to -1,
Okay.
okay? And do we have any y-intercepts?
No.
We said we don't have any, right?
Mhm.
Okay, so next what we're gonna do is we're gonna find how this graph behaves on the vertical asymptotes. So what we're gonna do is we're gonna start at x equals to -4 first, okay? And we're gonna see what happens to the left of -4 and to the right of -4, all right? And let's start, see how this graph behaves to the left of -4. Let's say it at -4.1, -4.1, okay? And let me do it right here. Let me do it right here. At -4.1. Everybody? Okay? So what we're gonna do is we're gonna plug in this value in f of x. Okay? So this is f of x, you guys, which is x plus 1 divided by x times x plus 4. And what we want to know is what happens when we plug in x equals to -4.1 in f of x. In other words, we're going to evaluate f of x at -4.1. And all we care, you guys, is what will be the sign at the end. Notice. Let's do it together. What if we plug in -4.1 in the numerator? What is -4.1 plus 1? What is the sign that we have in the numerator left?
Negative.
Negative 3.1.
Yes, that would be a negative, right? Yes?
Yeah.
All right, let's do the same in the denominator. Let's plug in the -4.1 instead of the x. Let's start inside the parentheses. What is -4.1 plus 4? What?
Negative.
You have a negative, right? You have a negative here inside, right? In the parentheses. And notice also outside, you also have a negative, right?
So it's positive?
Yes.
So negative times a negative becomes positive in the denominator, right? You're right, Sherry. Is that clear? So now, what is negative divided by a positive?
It's negative.
Negative, right? Everybody. This negative tell us that the graph on the left of -4 goes down here. That's what it tells us right there. Is that clear? That negative sign tells us that the graph is going to go to -infinity on the left of -4. Is that clear so far?
Sir.
Okay. So now let's do the same, but now, yes, question?
Would you get -4.1?
Oh, okay. So how I got that -4.1? We're going to evaluate, see the vertical asymptote goes through -4. So what we want to do is what happens to the graph close to the -4. So I'm going to choose a point close to -4 to the left of -4. That's why I chose -4.1.
Okay.
Can you just choose 5?
Yeah, my recommendation is use a point very close to the vertical asymptotes. That will give you a better idea what's going on, because we want to see what's going on very, very close to the vertical asymptotes.
Even if it's a decimal?
Yes, definitely.
Okay.
All right, so now let's do the same, but now we're gonna do what happens to the right of -4. Let's say what happens at -3.9 now. Notice, a -3.9. We're gonna do the same analysis as we did before, right?
Why do we have to do the second one?
We had to do it, notice.
On both sides?
On both sides, yes, because we wanna know what's going on very close to the vertical asymptote on both sides. Okay? we're gonna do the same analysis in every vertical asymptote. So let's evaluate f of negative 3.9. Let's see, we care about the signs, you guys, only, about the signs. Okay? Okay, let's plug in negative 3.9 in the numerator here. What will be the sign in the numerator?
Negative.
Negative, okay,
Negative.
very good. Okay, what about in the denominator?
Positive.
Well, if we plug in the negative 3.9 here inside the parentheses, that's a negative, and also here's a negative, that would be what?
Positive.
A positive? Okay. Everybody agrees?
Mm-hmm.
So, okay. So negative divided by a positive is also, yes,
Negative 3.9 plus 4 is a positive times outside negative 3.9, making it a negative.
Oh,
Yeah, you're
all
right.
right. Yeah, you're right. So let's go over that again, okay? Negative 3.9 plus 4, that would be a positive inside, right? You're good. Yeah, pretty good. And we have a negative side. So negative times a positive is negative. Pretty good, thank you. So negative divided by negative is what? A positive, right? So this positive tells us that on the right side of negative 4, the graph is gonna go up this way. See that?
Mm-hmm.
Pretty good? Okay, so we're gonna do the same analysis at the other vertical asymptote at x equals to 0. We're gonna do the same. And we're gonna do at x equals to negative 0.1, very close to x equals to 0, negative 0.1. Let's see what the signs are there. F of negative 0.1. What would be the signs there, you guys? All right, let's plug in negative 0.1 in the numerator. That will be a positive in the numerator, right, everybody?
Mm-hmm.
Is that clear?
Mm-hmm.
That would be a positive. What about in the denominator? If we plug in negative 0.1 here, I got a positive here and a negative outside. That would be a negative, right?
Yeah.
Everybody?
Yes, that would be a negative.
And that would be a negative, right? So here, on the left side of this vertical asymptote at x equals to 0, since we have a negative, now also it's gonna go down right here. Is that clear so far, you guys?
Yes.
All right. Now, last step, you guys. We're gonna evaluate. Well, we got more steps, but we're gonna evaluate to the right of the vertical asymptote at x equals to 0. At x equals to 0, you guys. At x equals to 0. At x equals to the right of 0, by the way. Let me choose 0.1. So what happens here? At what is f of 0.1? Let's find the signs here. If we plug in 0.1 here, in the numerator I have a positive, and in the denominator we have what?
Positive.
A positive, so we have a positive, right? So here, to the right of 0, we have a positive. Is that clear?
Yeah.
Okay, now, I'm gonna show you a shortcut, you guys, now, okay? Notice we did all this analysis right now, but let me show you a shortcut. You guys ready?
Yeah.
All right, very good. Notice, let me go back to the graph right here. Notice that on the left side of the negative 4, it goes down, and on the right side of the negative 4 goes on the opposite direction. See that?
Mm-hmm.
Also the same for x equals to 0. On the left side goes down, and on the right side goes on the opposite direction. All right, so let's go back here. Let's go back here to this function, to the original function right here. Remember the term multiplicity, you guys?
Yeah.
Odd multiplicity and even multiplicity? Yes? All right.
Yeah.
Notice that the two factors here, x is odd multiplicity because the degree is odd. Okay, and the same for x plus 4. X plus 4 by itself is odd multiplicity because the degree is odd. Okay. When we have odd multiplicity, you guys, in the denominator, always, all the time, when we locate the vertical asymptotes, they're always going to have the same behavior as the graph right here. One of them is going to go, the two graphs on those vertical asymptotes are going to be in opposite directions all the time. One of them is going to go down and the other one is going to go up. See that right here?
Wait, can you tell us the rule again?
Yes, yes. Go back to f of x and check the multiplicity. If the multiplicity,
Can you go over multiplicity?
yes. Okay. So what is multiplicity? Okay, remember, we have two kinds of multiplicities. One is odd and one is even. When the multiplicity is odd, okay, apply to this what we're doing. If this multiplicity is odd, what is odd numbers? 1, 3, 5, and 7, right? Here
you look at the degree.
The degree, yes. Here is 1 and here is 1, right? That means that the multiplicity is odd, okay? If the multiplicity is odd in the denominator, all the time, the graph close to the vertical asymptotes go in opposite direction. One goes down and one goes up. Notice, for both of the vertical asymptotes, they go in opposite direction. One goes down and the other one is up. So that's a shortcut all the time that we have odd multiplicity. Is that clear?
Professor?
Yes,
If we go to the original function, it's x squared plus 4x. It's
yes, x times, here,
even.
x times x plus 4. Notice, here the x has odd multiplicity and x plus 4 also has odd multiplicity.
Oh, okay.
Is that clear?
Yeah.
That's the one I've heard. If you guys had even multiplicity, the graph in both sides of the vertical asymptote goes to the same direction, by the way. Okay, so we'll cover a case like that. But now let's continue with this graph really quick. We're almost done, okay? So now that we found this, the last thing that we're gonna do, you guys, we're gonna see what happens on the horizontal asymptote. What happens along the x-axis? Let's do it really quick. To see what happens along the x-axis, we're gonna do the same with f of x, but now we're gonna evaluate at large values of x. Let me do it right here. For example, evaluate what happens at f equals to 100. What happens? Plug in the 100 right there. So, and you can use your calculator. What is 100 plus 1? That would be 101 here, right? And in the denominator, that would be 100 times 104.
Professor, where'd you get 100?
Oh, just you guys pick a value here for large values of x. That could be 1,000 or 100. You guys choose.
Why can't it just be 10?
You get a better idea when you choose a larger value than 10.
Okay.
Like 100 or more.
Okay.
Okay. So use your calculator really quick, and let's do the division. That would be 101 divided by 100 times 104. All right. Notice the value that you get. You get positive 0.009. Is that clear, everybody?
Yes.
All right. So that means that the line is going to be very close to 0, which is the x-axis, but it's going to be above the x-axis because this value is positive. So that means that this graph is going to come down right here, and it's going to get closer and closer to the x-axis. Never is going to touch the x-axis, but it's going to get closer to the x-axis. Is that clear, you guys?
Yeah.
That's what it means. All right. So let's do the same on the left side of -4. Let's pick, let's say -100. Let's evaluate. Now it says choose x equals to -100. And now let's evaluate f at -100. Let's see what we get now. So that would be -100 plus 1, that would be -99 divided by -100 times -100 plus 4, that would be -96. So let's find these values really quick. Using your powerful calculator, that would be -99 divided by -100 times -96. And notice, it gives me a negative value, by the way. This is a -0.01, notice, everybody? The negative tells me that the graph is gonna go below the x-axis, but very close to the x-axis, by the way. So this is how the graph goes, you guys. So this is how the graph goes now. It's gonna get very, very close to the x-axis. Is that clear, you guys?
Why is it off?
Can
Why
we
is it
just?
off?
Oh, sorry, you first.
Why is it off that one and not off the y-axis?
Again, Nadia, go over again.
So you put the imaginary line there, right?
The horizontal asymptote, remember, is along the x-axis, right?
Yeah.
So when I plug in the -100, I get -0.01. That tells me that this graph is gonna go below the x-axis, but very close to 0. Notice. It's
I'm saying, why won't it go to the right of it? Like, see, like, go to the right.
To the right? No,
Yeah,
because
why won't it
notice,
go that way?
but notice, it's not possible to go to the right here, because remember, the graph never crosses a vertical asymptote.
Oh.
Never, never, never. It's not possible to go to the right here.
Okay.
So there's
Okay.
just like a random point on the x-axis then?
Yes, like a large point right there. Okay.
Just
So now let's finish the graph right here. Notice that we have an x-intercept at x equals to -1, you guys, which is right here. Okay. So if you guys evaluate f of x, let's say at -3 or -1 right here, notice this is how the graph is gonna look now. I'm gonna go up and it's gonna cross the x-axis at x equals to -1, you guys, and then it's gonna go this way. It's gonna go up, and this is how it's gonna look, you guys. That would be the graph, you guys. That would be the final graph.
Can you just like draw it all just by visual without doing the steps, or you have?
That would be like magic right there, Cherry. Okay. Okay, that's that. I mean, yeah. So we need to show those steps right here. Okay.
Okay.
Alrighty. Okay, you guys. Now from the graph, we can find the range, you guys. What would be the range right here?
Is it negative infinity to positive infinity?
You're right. That would be the range. The range would be from negative infinity to positive infinity, by the way. Thank you, Cherry, everybody. So the range is from negative infinity to positive infinity. So my recommendation is finish the graph, and from there, you know, because sometimes the range is gonna be a little bit tricky, and we're gonna find it when we finish the graph. So you guys, thank you very much. We're gonna finish here today, you guys. Please give me your feedback. You know, what is it that I can do better, you guys? So I can see your chats also, you guys. You know, I can see it right here, and thank you, you guys. And send me an email, tell me right here through the chat, how can we do this better? If you like what we did today, we're gonna keep doing it the same. We might change it a little bit also, but if you think that is okay, And let me know if this something is off or if something is not working on my side. Please let me know as you guys do, okay?
Okay.
If nothing else that you guys, any questions, I mean, I'm gonna stay here for a couple of minutes more. If not, I'll see you next time. So I'm gonna assign homework for these 2 sections. And again, I'm gonna upload this video on YouTube for you guys to go over on your own time. And thank you very much, you guys, and keep safe and healthy.
Thank you.
Ready?
Could we go over
Yes.
long division?
Sure, yes, definitely. I can go over long division, all right? So if you guys want to stay a little bit more, let me pick some exercises for long division, and then definitely we can go over long division. Let me get one exercise right.
Somebody's asking if you took attendance.
Yes, actually, the program that I'm using right now, it records all your names, you guys, by the way, okay? So, yes, the answer is yes. All right, so we're gonna go over long division. Let me pick some exercises here. Let me get my book here. I have it right here with me. And let me go over long division.
Some people, they left already. Right now we're
Yeah.
20. It was
Yeah,
28.
no problem, you guys. So probably some of you already know long division. For the ones who want to stay and going, let me go over long division. No problem. You guys can stay here. So
Okay, thank you so much, Professor. Bye-bye.
you no problem. So let me just get a couple of right here. Long division, functions. All right, so let's try this exercise, okay? This is long division, you guys, long division. So we have h of x is equals to 3x to the 4.
Can you focus it? It's not.
Yes, let me write it and I'll focus it right now, okay? 3x to the 4. You know what, let me do it right now here.
Yeah, this way I can keep up with you.
Yes, 3x to the 4 minus x squared divided by x cubed minus x squared plus 1, all right? All right, so let's try that one. This is long division. Remember, first thing, how do we know when to use long division? Well, that's when the degree of the numerator is larger than the degree of the denominator. That's when we use long division, okay? All right, so let's set up the division. So remember that the numerator, that's the one that goes inside the radical right here. But also one more thing, check if you have missing terms in the numerator. So we have, let's start with 3x to the 4. 3x to the 4, right? Notice that we're missing x cubed, right, everybody? So use 0 as a placeholder. So that would be plus 0x cubed, all right? Notice that we have x squared. That would be minus x squared. Also notice that we're missing the x.
Why don't we do 0x squared?
Because the x squared is right here.
Oh, okay.
We only use 0 as a placeholder for the ones that are missing, yes. So plus 0x, all right?
Okay.
Notice that we don't have a constant. You can also add a 0 right there, like in place of the constant. Now we're gonna be divided by x cubed minus x squared plus 1. Notice we're gonna write it x cubed minus x squared. Notice that the x is missing in the denominator. We're gonna use also 0 as a placeholder in the denominator. That would be plus 0x plus 1. That would be the initial setup. Let me, everybody okay so far? All right. Now let's start finding the terms in the quotient. So all the time we start with the first term in the radical, which is inside the radical, and I'm gonna write 3x to the 4, and always we're gonna divide by the first term in the divisor, which is x cubed. So what is 3x to the 4 divided by x cubed? That would be what? 3x, right? Everybody agrees? Okay, now this 3x, place it on top of the 0x right here. That would be the 3x right here. All right? And then we're gonna start multiplying.
Can you hold on and go back to the first step? How did you get the 3x to the 4th power?
Okay, the 3x to the 4th power, that will be the first term right here inside
So you always go for the first term?
Yes,
always go
all
for
the
first term
time.
and
Yes, that's
and
how
put
you
it
started.
over,
Mm-hmm.
and put it over the outside first term.
Correct. The leading
Okay.
terms. All the time.
Okay.
Good question. All right. Now that you got 3x, now we're going to start multiplying 3x times 1, which is 3x. And I'm going to use a different color here. 3x times 1 is 3x. Place it right here underneath the 0x. And then notice 3x times 0x, that would be 0x squared. All right. So if you want to write it that way right here, that would be okay, no problem. And then 3x times negative x squared, that would be negative 3x cubed. Here would be negative 3x cubed. 3x times negative x squared is negative 3x cubed. And then 3x times x cubed, that would be 3x to the 4. Is that clear so far?
There's a missing sign.
Yeah, here, write the positive. That's okay. Write the positive sign right there.
Okay.
Now, remember that we have to negate, right? So we're going to negate everything here. We're going to negate everything. This negative sign is going to be affecting the signs inside the parentheses, by the way, okay? And I'm going to write it in red. This negative, because of this negative sign, the 3x to the 4 is going to become negative. Because of this negative sign, this negative 3x squared, negative times a negative becomes positive. Because this 0 does not affect the negative sign because this is 0. But this positive 3x, because of this negative sign, is going to become negative right there, okay? And now I'm going to add these terms right here. 3x to the 4 minus 3x to the 4, these two cancel out. That's 0. This is 0 plus 3x cubed. This would be 3x cubed positive. Here, negative x squared plus 0, that would be bring down the x squared. 0 minus 3x, bring down the negative 3x. Okay. All right. You can bring down the 0 you want to. That's okay. You can do it this way. Is that clear so far, you guys?
Yeah.
All right. To get the next term in the quotient, get the leading term in the remainder, which is 3x cubed. 3x cubed. And always divided by the leading term in the divisor, which is x cubed. So what is 3x cubed divided by x cubed?
Wait, where'd you get the x cubed from again?
Again, the 3x cubed, which is this 3x cubed, divided by, always you're gonna divide by the leading term in the divisor, which is x cubed.
Okay.
This x cubed is this x cubed.
So it'd just be 3.
That would be 3, yes? That's positive 3, right? So that positive 3, you add it right here, plus 3. Okay?
Okay.
And then you're gonna do the same as we did before. We're gonna multiply 3 times 1, which is 3. Just write it underneath the 0. 3 times 1 is 3, just write it right here underneath the 0. And then 3 times 0 is 0, okay? So you can add the 0 right here. And 3 times negative x squared, that would be negative 3x squared. And then 3 times x cubed, that would be 3x cubed. Alrighty? And don't forget to negate. And remember, this negative sign is going to be affecting the sign of the terms inside the parentheses, right? So here, this becomes negative. Negative times a negative becomes positive here. And this 3 becomes negative also. And then last, we're going to be adding these terms right here. 3x cubed minus 3x cubed, this becomes 0 right here.
Wouldn't it be minus 3? Oh, yeah, it is minus 3.
It's minus, yes. So here, negative x squared plus 3x squared, that would be positive 2x squared. Here we have negative 3x plus 0, bring down the negative 3x. And here would be 0 minus 3, that would be negative 3. That would be the remainder. Now, excuse me, here we're done. How do we know we're done, you guys? Always check the leading term in the remainder and check the degree.
Okay.
If this degree is less than the degree in the divisor, which is 3, we're done. Okay, so here the goal was to find the oblique asymptote. So the oblique asymptote
Is 3x plus 3.
You're right. That would be 3x plus 3. That's how we find the oblique asymptote using long division. Ready, you guys?
When do we use this?
When do we use this? Well, remember that to graph, we're going to be doing one exercise on Wednesday. And to graph the oblique asymptote, that's how we're gonna be using it.
No, I mean, like, what rule?
What? I'm sorry, again?
What rule? Like, you said if n equals n plus 1?
Yeah, okay, when do we find an oblique asymptote? When the degree of the numerator is 1 more than the degree of the denominator.
Oh, okay.
Okay, that's the rule.
Okay.
You ready? All right, you guys. So you guys don't have any more questions. Thank you very much. I'm gonna upload this video later on, and also I'm gonna assign homework for these 2 sections. Already?
Okay. And what if we need help with the homework? Because the math lab, I don't know what they're doing.
Okay. You know what? Good question. I can always I can always stay after lecture. That would be good. Okay. Nadia, send me an email on Canvas in case I'm available and you need help. I can log in and go over with you.
Okay. All right.
But usually I'm gonna stay a little bit more after lecture also. Okay.
Okay.
For my office hours. Any questions, you guys? Yes.
Like you know what happened to my quiz? We talked about it.
Yes. Kip, I'm gonna look for it right now.
Okay.
And I will let you know. Okay. But thank you for reminding me.
Thank you so much.
That's quiz number 2, right? No, number 1, right?
1, yeah.
Number 1. Okay. All right. I'll take care of that right now. Thank you.
Thank you so much, Professor.
All right. You guys have a good day and take care. All right.
Bye-bye.
Bye-bye.